We're going to be modeling this pencil in Fusion 360. And I assembled it in the Inventor modeling video, but since I didn't have the pencil to see how it went together, I struggled a little bit. So I think for this video, I'm just going to model the parts and call it a day. If you want to see it assembled, you can maybe leave a comment, and if there's enough interest, maybe I'll follow up and assemble it. So I'm going to start with PP01. If you can download this, put the link in the description. And the assumption here being that you'll kind of watch me model the part and then pause the video and then you go model the part. I'm not going slow enough for you to necessarily follow along. It's not really my intention. It's just to kind of show you the steps that you should take to model in Fusion. So PP01 is pretty straightforward. There's a number of ways this could be done. And then you would set your material. So go find steel. And save it. And I tell you what, let's make a new folder here called and this is going to be, and we'll go to a new design. So this workflow, I'm going to be drawing them all as separate parts. You can also do all these in the same part, in the same file, and save them as separate components. I'll do that maybe in one of the next videos with a different design. So this is PP02, the cone. I'm going to start with the center line. So I'm going to set my height with 0.638. Make that a center line. That kind of sets my scale. And then I'll draw the rough shape. Something like this. And that line didn't turn black, so I wasn't straight enough for it to catch horizontal. And then we'll just dimension this up. So the top is 0.087. Our bottom is 0.328. And the top of that little bevel is 0.273. And I'm going to kind of drag this into position before I dimension it, or it may end up stuck somewhere. 0.252, and then I'd have to delete the dimension. So now I just need some heights. 157, and this height is 0.169, and that looks like it's fully constrained. Grab a corner, kind of move it around, it looks fully constrained. So I'll finish sketch and revolve. And then we need to do some cutouts in the middle. I'm going to start with a counterbore hole. And this will be not a through all, so the total distance, I'm going to go down to where the bevel starts, so 0.315. And my top counterbore diameter is 204, depth of 0.203. And then my bottom bore is 0.138. And then we'll put another hole here. And that'll just be a through hole. We'll say through all. This is the small hole at the bottom of it, 0.035. So we still have this, there's like a angled hole in there. Other than putting some planes to define the bottom, I think the easiest way to do this is just put a sketch on a cross plane or a sectioning plane and capture some geometry. So I'm going to project this line and that. Not even sure that I needed that. Okay. And then I'm going to bring this up to here and then over to center. And then let's do a vertical alignment to put that right in the center. I'm going to make this line a center line. And then I just need that bottom diameter, 0.11, and a height. I think that is fully constrained. Finish sketch. Oh, that is not fully constrained. Let's go back in that sketch. I thought when I projected I got that top line, but it doesn't look like I did. So now it's fully constrained. We can revolve that profile. And it already found our center line. We're going to do a cut. So now we have that taper. We can look at this if you want to see the center. I think we got what we're after. And then this is where in the inventor part, we found some of these pieces weren't threaded. So this would probably be where we would add some threads here. Probably UNEF. Something like that. And in Fusion, you can actually have it cut those threads if you wanted to 3D print this. It looks like really deep threads, but this is really tiny, so it's not that big of threads. UNEF is pretty fine. All right, we'll save this as P02, and we'll move on to the next one. PP03. Pretty simple. Again, we could do two circles just like we did for PP01, but since I have a wall thickness, I'm going to do it like this. This is how I like to do things that I know the wall thickness of. I like to use a shell and then type in my wall thickness. And that gives me a shell feature in the browser, which makes it a little easier to identify. So wall thickness is a pretty common thing that's changed, and instead of trying to find the feature that makes the wall and then go into the sketch and edit the dimension, it's real quick to just edit this feature, and the only thing that's in it is your wall thickness. This is how I like to do these. So PP03 is done. Of course, we would maybe add some property data and set the material and appearance, but in this video, I'm just going to be modeling these. PP04, I think I stacked two circles or two cylinders on top of each other when I did the inventor video. This one, I'm going to do it a little different and make this line a center line. This is a quick way to do a shaft or something with a couple different sections. 0.118 and 0.071, and this is 0.173, and then my overall height is 0.299, and I was zoomed way too far out, so my dimensions are pretty far out. Finish sketch and revolve. I got to hold control and pick that other profile. It only grabbed one for some reason. And then we'll do a counter bore on the bottom. Counter bore hole. Counter bore. And this will be a through all. Counter bore is 0.051. A depth of 0.069 and a through hole of 0.039. So you set your material and save it. This is PP-04. PP-05, new design. I'm going to start this with a revolve as well. I'll set my scale by typing my center line, 0.394. That way I'm somewhat close in size. Make that a center line and then draw this rough shape, sloppy. Not that sloppy. So this isn't horizontal, so let's make this horizontal. And you see I added a parallel by accident. And this line is not parallel, so I need to get rid of that parallel constraint. And then let's dimension it up. So the top diameter is 0.055. And the bottom of the little bevel there is 0.0. I see this one. This one is 0.51. This one is 0.055. And let's push this down before I get confused. So that would be 0.325 minus 0.01. Okay. And then let's bring this down before I get all mixed up. Bottom diameter is 0.098, and this diameter is already set by my 0.055. Okay. So just some heights are left. I think that's fully dimensioned. I can revolve. Only one profile, only one center line. It just revolves. This through hole is tapered with 1 degree, so I'm going to put a sketch on the bottom. I can't use the hole command for this because I want to extrude with a taper angle. And that's it. We'll extrude that. We're going to go this way. Hold Shift, deselect that. Well, we'll try it again. E for extrude, and drag that up. The distance is going to be all, and I'm going to have a taper angle of 0.05. And just to make sure it's going the right way, I'm going to see 3, and it is tapering the way I want, so I'll say 0.5, and that would give me a 1 degree between walls. Then we have to put this lip on the top. we could pull a work plane down and draw a circle, or we could just put a sketch on a plane that runs through the center so that you can see where I'm at. I'll slice my graphics, and I'm going to project this edge and I said 0.325 minus 0.01, so I actually started this at the bottom, so I need to angle up. So I'm going to also project this edge. So I'm going to start at that corner and go over and up and then back. So this is 0.005 and the whole thing is 0.01. And then we'll go off of here to here. That is going to be 0.087 divided by 2. That should be fully constrained. It can't go up or down because it started on that point. So we can revolve that. And the axis is just picking something round. I do have it set as join, not as a new body. And that should complete PP-05. New design. This is going to be PP-06, the shaft dispenser. We've done enough revolves. I think this time I'm just going to do 2 cylinders stacked on top of each other for this basic shape. So the bottom one is a diameter of 0.219, and I'm going to extrude that up 0.48. Then we'll put a sketch on the top and do a new circle that is 0.201. And I'm going to extrude that up. I don't want it to be a new body. I want that to be a join. And that's going to be 0.787 minus 0.787 minus 0.48. And be careful with that when you start your new features that your secondary features are set as join, not as new body. You're going to create a whole bunch of bodies sitting on top of each other. Do a counterbore hole for the start here. This will be a through all. And see, I'm on the bottom, so 0.165, a depth of 0.787 minus 0.236. So I took the overall length minus the 0.236 because it is dimensioned from the other side. If I would have seen that, I probably would have made this top my counterbore. There we go. And not a counterbore and not a through all, so the depth for the top is 0.087 and a diameter of 0.134. That doesn't look right at all. Let's edit this first hole. I don't think I have the second hole right. That should be 0.118. 165. Yeah, I think that's right now. So the only thing left are the little flat sections that run around the side. So I'm going to put a sketch on that face and draw 3 lines off of it. I'll put an equals between these 2 lines. That will force it to be centered. And then I'll only need 2 dimensions. The width is 0.057 and the depth 0.102. That should be all I need. That should extrude. So let's see, why did you pick all of that? Let's try this again. Go that way. So it's going to be a negative 0.094. This will be circular patterned. Around this axis. And it is 6 times. And I think that completes that part. So let's save that as pp-06. The next part is the spring, pp-07. So you can't draw your profile and coil. You start with the coil and it kind of builds it all for you. So what's the diameter of the spring? This is the center line of the spring, so 0.106 plus the wire, so 0.02. That would be the center line. And then I have everything else in here because, well, not quite. I was playing with the coil command earlier. It is diameter 126, revolutions 9.25. The height is 0.366. The shape is circular. The section, that's the wire diameter, is 0.02. And if it goes the wrong way, you can flip it. This way matches my print with that rotation pushed in. Now when you go to constrain this into place, a joint, I got turned into a component. Just to test this, I'm going to make this into a component. And constrain off of my origin. That's what I expected it to do. So you're going to want this circle to be flat. So you pre-create the origin with a joint origin. And then you can pick your 0, 0 and redefine or reorient what is up and what is down. So the Z is going this way, and that's why that's sideways. I want the Z to go up, which is Y. And that flips my circle to flat. To be honest, I don't really care where X or Y is. I'm happy with that. So now when I bring this into the assembly, I'll be able to constrain it properly. I'm going to undo this. I don't think I had to turn this into a component to add a joint origin. So I could have done this here, then reoriented my Z to my Y and said OK. And that would have given me an origin. Tell you, I could even pushed it down. Let's edit this joint origin and push it down. I didn't want to delete it. I wanted to edit it. If I push that down, that tells me that this is the one that I'm moving. So I'm going to go down half my wire, 0.01. And now my joint origin is exactly on the bottom, which is going to make this constrain much easier. Save this as pp-07. Should probably be adding a name to these file names as well, but PP08 is this little dispenser ring. It looks like a cup or a bowl. We could draw a cross section. We could do something like this, right? We could draw this cross section and revolve it. Get a lot in there. But the first thing I look at when I see angles and stuff, the first thing I always look at is if it has a consistent wall thickness, because if it does, I can just draw that outside shape and shell it, and it looks like it does have a consistent 0.01 wall thickness. So knowing that, I will create the top lip and then extrude it down. Now let's start at the bottom, then I don't have to create a work plane. So if I start at the bottom, my diameter is 0.109, and I'm going to extrude this. Let's go this way so we can type in positive numbers. I'm going to extrude this 0.075 with a taper angle of 10. It says, it shows you the 20 degrees, so that's going to be a taper angle of 10. Then I have something to put a sketch on and draw this outer ring and extrude that up. Now to get my consistent wall thickness, I'll say shell, remove that face, and I want a thickness of 0.01. And I should have a consistent wall thickness of 0.01 all the way around. Since I'm given the top and bottom circles for this hole that's tapered at the bottom and I'm not given an angle, I think the easiest way to do that is put a sketch on this face of 0.063. And we'll put a sketch on the other side of 0.063. I messed up the top one. Sketch. This one is supposed to be 0.075. Okay, and then we can loft between those. So if I choose loft, I can pick that circle and this circle and say cut, and it should not sure what all of these profiles are that I picked, so I'm going to repick these. So I want this profile going to this profile, and I want that as a cut, and that should give me that exact taper at the bottom. The last thing we need are some 0.004 fillets on this edge and this edge and this edge. 0.004, not enough zeros, and that should complete PP08, PP09. When I did this on the inventor side, on the inventor video, I stacked cylinders, 1, 2, 3, 4, 5. I stacked 5 cylinders on top of each other, and it got a little bit more in time in consuming than I thought it was going to be. So this time I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to slightly violate my rule of no more than 8 pieces of geometry in a sketch, but that is a rule of thumb, not a law. So this is my overall length. And then I'll draw this shape. So something like this. Okay. And this one goes way down here. And we go out again. Then we go in and end. And I didn't get a black line on the bottom, so I have to say horizontal and fix that. And I think I will set all the diameters, and I'll just start at the bottom and work my way up. 0.197. And then I'll start at the bottom and do all of the heights. 0.244. This one is 0.197. 0.165, and then the last one is 0.118. Then we're going to start at the bottom, and we're going to set all these heights. 0.256, 0.469, 3.035, 3.78. And that should be fully constrained. And that definitely was faster than stacking the cylinders like I did earlier in the Inventor video. Cut these holes out. We've got a counter bore hole from the back with a chamfer on it. So let's do this first. We'll do a counter bore. It's not going to be a through hole. It's going to go down 3.701. The counter bore diameter is 0.163, a depth of 0.256, and then we'll chamfer the inside hole, and then the through hole is 0.150. And then this, we will chamfer this back. So how much do we need to chamfer this? Let's measure that edge against that edge, and the minimum distance is 0.005, 0.0065. So chamfer on that edge, 0.0065. That should take us right against. There is a hole through here yet, though. It's going to just be, we'll say, through all 0.071. Oops, I didn't center it. There we go. And I have a chamfer here, but I don't know how much. 0.0235 is my minimum between these two. 0.0235. Okay. I think this, no, we're not quite done. We have to do a cutout on this face. So I'm just going to draw two lines. Put an equals between them. And then I should only need one dimension because they should be over centered over center. 0.097. And I'm going to get out of any command and just try to move them, and they look fully constrained. And I can extrude that. It's going to be a negative 126. All right, that is PP 09. Shoot, I didn't put a dash in it, so I want to fix that now while I'm here. Let's go into rename. There we go. PP09 is done. PP10 is the little grip. So new design. I'm going to assume that the chamfer there is a 45. But I can't be sure because I'm given dimensions. It's not called out as a chamfer. Don't yell at the name that's on the print. I'm the one that made these prints. I got the model from Mark Flaler and I made all of these prints. So if you don't agree with how something is marked up in here, it is not his fault. All right, I'm going to give myself a center line, 0.1606. That's not right. 1.606. Make that a center line. And draw this shape, and then I'm going to actually draw the grip as a solid. I missed. And didn't get horizontal either. I'm getting a little sloppy. So this is 0.272, and this is 0.315. This height is 197, and this height is 219. These are collinear. There's a lot of ways you could line those up: horizontal point to point, coincident point to line, or collinear. I like collinear because it shows the constraint symbol and makes more sense when someone goes to look at it, as opposed to a coincident constraint. I'm going to push this 0.06 off, and then I'm going to carve out what I don't want, but then it's only going to stick out 0.011. So this line is 0.011. And then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13 sections. So this is going to be this section of 0.091 times 13, so asterisk 13, and that should fully constrain this, and I can revolve. We've got a straight through hole, so we might as well get that out of the way. Distance will be all, and 0.224. I'm pretty sure this is threaded. Based off of my attempt to assemble this last time, but we need to carve out this little grip. So I'm going to put a sketch down. Let's do the top first. I'm going to put a sketch on this face and draw a circle, vertically align it, and it is a radius of 0.026, and oh, I don't know this number. I need to project this circle, and then I can say tangent, and it's fully constrained. I can't change the height, I can't take it back and forth, and I can't take it up or down because it's tangent to that purple projected line. and I'm going to extrude that. As a cut. And I want to do a circular pattern around this cylinder. 1, 2, 3, 4, 5, 6 times 2. We have 12 of them. So there's those cutouts. Now we'll put a sketch, or look at a sketch. It's getting late. We will place a sketch on a plane that runs through the center. And I am going to project this line and that line. And I want, not sure why it didn't give me this. Okay, so I'll do a circle just like we did on the top. We're going to do the same thing here with horizontal alignment and a radius of 0.023. And I think that's right. Extrude, no, revolve. And my axis is this cylinder. I think that is right. And then we're going to rectangular pattern a feature. This is the feature. It selected a bunch of stuff there for some reason. Not sure why it's doing that. I'm going to select the feature down here in the timeline. Just selecting all kinds of stuff up here. My axis, I'll pick the y-axis, and I want 14 of them, it looks like, and they are 0.091 apart. .091 apart. Okay. And I think that's what we're after. Save this as PP-10 and go to the next one. PP11 I don't think I need to do. I think you can get this one on your own, but it's quick enough. 0.335, finish sketch, extrude, 2.299, shell, .008, and then we have a tube with a shell feature, making it easier to change that thickness. PP11 is done. PP12, new sketch. We haven't stacked some cylinders, so let's stack some cylinders for this one. In fact, let's use the cylinder command. 0.315, I'm guessing. Doesn't really say. All right, looks like we're drawing from right to left. So 0.232. And then I'm going to do a new cylinder on this face. And that is 0.268. And it goes up 1.807 minus 0.232. And then we'll do a new cylinder, 0.232. Oh, that's not right. 0.315, and the height is 2.618 minus 1.807. All right, we have a through hole here. Um, 252. And then we're going to build a little build up on this thing over here. So I'll put a sketch on this face and just draw. Why did it do that? And we'll do an equals and then dimension this up. 217 by 266. And we'll extrude that down, -472. There is a rectangle cut out on this thing, like right in here. So let's vertically align this. If you hold shift, you can get a midpoint. And then we'll dimension up this little rectangle, 0.028 and 0.177. And it's 160 from here. And that gets extruded down -0.354. And I'll tell you what, let's cut off these little ears. I'm going to put an equals between this line and this line and this line and this line. And then dimension across is 0.118, and it looks like it gives it to me from here, 0.227. Those are getting cut off, so I'm going to extrude you and you to you. And then finally there's a little cutout on this face that is from this line, and it's just cut out .031, and That's going to get extruded to that face. And more than likely, after I've seen how that goes in, there's probably a slight fillet there as well. The clip goes down in and has to bend up around. So I think there's probably a small fillet on there. Wouldn't surprise me if there's some threading on this part too. But we're going to call this part done. Save as pp dash, what is that, 12? Yep. So I'm saving all of these, and one day I may put this together in Fusion. I'm not sure yet. PP13 is the clip. I did this as a sweep in Inventor on the Inventor video. I think it should probably be done the same way here. Looking back on that other video I seen when I was editing it, I seen that I missed a fillet, and I thought I seen one other thing that I did wrong on this part. But let's do the clip. We're going to draw the inside, and I want my axis to be the since the bottom of the drawing that is what is going to stick into the part or into the other piece. I didn't think about that when I was drawing it before. I'm going to make that my origin. So this is a radius of 0.071, and then coming off of this, let's do this again. Coming off of this, if you hold shift, it'll keep your line tangent. And this is going to be aligned and 0.335. Then we'll do hold shift and get that tangent for sure. Then I can do my 1 degree. Constraint was removed. What was removed? I don't think anything was removed. Not sure what it removed. It might have pushed my angle dimension way down into nowhere, but I think I'm still safe to keep working. Do another circle up here. This one had a radius of 0.051, and I'm going to constrain it to that point. And then come down a little bit, and then make it tangent. And then from this point to this point, I had 1.38. Got a line coming off of here that's tangent straight down, and that was 0.13. And then this guy came down, aligned 224 at a 20-degree angle. And what I missed was this fillet right here of 0.031. All right, let's see if anything moves. I think we're still fully constrained. I do need to trim this out. Oh, come on. Let's see what this tells us. Nothing. It tells us nothing. Okay. I mean, I've been watching it and it doesn't seem to be removing anything. I think that's a warning, and if you hit more info, it would have told us what was actually removed. That's our inside path. I'm going to put a sketch on this plane. And project this point, and that will be where I constrain my rectangle. So U to hold Shift U, and then my little flat piece of metal is 0.028 by 177. And then I can sweep this. That's my profile. That's my path. And okay. And I think that is that part. PP-13. Now we got some easy parts and then we wrap it up. So PP-14 starts off with 157 and it goes up 0.413. It has a fillet on both sides of 0.02. That is the eraser. So then you could set the material and then you could set the appearance. Wonder if there is an eraser appearance in Fusion. I haven't ever looked for that. But it is PP15. It's almost 2 in the morning, so I'm going to wrap this up. New design. This is the cap. 0.248 and extrude of 0.551. We will put a sketch on the top and cut out our hole of 0.209 and extrude that down, so negative point. Oh, I don't have, okay, so 0.551 minus 0.039. Oh, I'm going in the negative already, so I need to say plus. And then add a fillet of 0.02. There are all of the parts modeled for this PDF. I did not plan on you following along. The goal here was for you to see it done, and then you can go back and practice modeling, and hopefully having just seen it done, it might give you some better idea of how to tackle the parts. Good luck modeling. Have fun.